good. All right, well, thank you, Ben. I'm Tracy Kozloff from the Colorado Division of Water Resources, here with Megan, our co-host from CWCB, and Ben as well. And today I'm just going to be running the agenda, but as most of you know, most of the information comes from our presenters from the state climatologist, as well as the NRCS. So before we jump in, I did want to ask, I'm going to admit somebody else. I wanted to ask, could everybody in attendance please just go ahead and write in the chat to all your name and what organization you're representing. And I'm asking for this in particular because I'd like to, when we get to the part of our agenda about water providers and discussion, it's good for me to understand who all is represented on the call. I may call out specific folks and ask if you have anything to report about conditions in your area or in your sector. One of the things that we really want to try to do is get good geographic coverage in terms of condition reports, as well as if we can cover a range of sectors, not just water providers, but also if we have folks on representing ag or wildlife, it'd be great to get some reports at the end of our meeting about conditions, what people are seeing on the ground, what they might be able to report. So that's the plan. And certainly if I ask, you're welcome to say, I just don't have anything to report. That's totally fine. But without further ado, I guess I'd like to ask, does anybody have announcements? I don't have anything. Peter?
No announcements, but I can start my talk if you'd like that.
Sounds good. I just saw like a yellow box go around you, around your name. That's why I called you out. But announcements or anything anyone wants to share with the group before we jump into Peter's presentation? All right. Yeah. Without further ado, then, Peter, please go ahead. Thank you.
Okay. Let's see here. All right. Can you see my screen?
Yes.
Yeah.
Perfect. And I know you can hear me, so let's go ahead and get started. Thanks everyone for being here this morning. My name is Peter and I work with the State Climate Office at the Colorado Climate Center at Colorado State University. And today I'll be taking you through just a little bit of a tour of recent climate conditions in Colorado. And then we can talk about the outlook or where we're going. And then we'll hand it off to Carl after that to talk about water supply conditions. So just a bit of a timeline for this talk. We'll start by looking at some of our climate statistics across the state from June. We'll put those in context and talk about how they've helped to shape the water year to date. And then we'll go over some month to date conditions as well as some kind of surface water balance conditions. And from there, we'll talk about the outlook. So first off, we'll take a look at precipitation across the state for the month of June. And you can see that for the month as a whole, it was pretty close to the 20th century average, just 0.08 inches or about a tenth below the 20th century average, and actually a little bit above the median because the distribution is a little bit skewed, where we're more likely to have a year below average than above average, with the above average years being well above average in some cases. But like always, you can see that the precipitation, even though it was very close to average, was not evenly distributed. We had an early start to the monsoon season, really getting going in that fourth week of June, and that led to some impressive precipitation totals across southwest Colorado. And we were happy to see that because that was an area that was really hit hard by drought in spring, well below normal precipitation throughout the spring months in southwest Colorado. So this was some welcomed reprieve. Then if we look at the northeast corner of the state, we see that in some areas, conditions were quite dry. Near the northeast corner of the state, even record dry. And well, actually, I don't think that's record dry. I think that's just top 10 dry. But in any case, quite dry. And that was unfortunate because that was also an area of the state that was quite dry in spring. So the dry streak continued for the area. Here's a look at statewide where we landed at 57th wettest or 72nd driest for the month of June. And you can see how that stacks up both in terms of looking around the country and how it ranks compared to other states, but also how it stacks up compared to other months in the water year to date. And you can see that we're kind of on a run, April notwithstanding, of months where we are near normal for precipitation. But then, of course, we had that very dry and windy April that was much below normal just a few months ago. All right, this is where we're at for the water year to date. So these are the 9 months starting October 1st of 2021 through the end of June 2022, or the first 3 quarters of the water year. Hard to believe we're already in the last quarter of water year 2022. And you can see that this map actually does show some record dryness and a lot of top 10 dryness in the northeast corner of the state or quadrant of the state. Again, these records go back to 1896. So we're looking at, I believe it's 127 or 128 years of record. For the state as a whole, we are down from the 20th century average by 2.38 inches, fairly close to that, even if we look at our last 30 years or our 91 to 2020 normals, as overall we haven't seen a large trend in precipitation across the state over time. We can see that we're closer to normal across most of the western portion of the state and over the high country, but the eastern plains in particular are well drier than normal, particularly after another dry month in June. All right, this is a time series of October through June precipitation, or precipitation for the first 3 quarters of the water year, with that last dot showing where we're at in water year 2022. We're at a statewide average of 10.16 inches, or a 2.38 inch anomaly relative to the 20th century for the water year through June, so not quite to date. And the last wet year was, of course, 2019, where we had an awesome streak of atmospheric river events in spring that led to a really good snowpack that really stuck around through much of the spring. But I think that a big part of or maybe the most important part of our drought story right now is if you look at these last 3 dots, they're all below normal. And yes, that's only 3 quarters of the water year. But if we think about what happened in July, August, September of those years, certainly we didn't see any recovery July, August, September of 2020. That was a disaster. If we look at 2021, yeah, we saw some recovery in some areas on the west slope, but overall, not so much. And then even if we look at 2019, our last wet year, the last quarter of the water year was quite dry. And so I guess my point here is just that we're in this long-term drought regime where we have not had as many weather events to get excited about over these last 3 years as we would typically expect. All right, now we're looking at temperature rankings, and this is average temperature for June. And I'm going to say it was warm, and I'll get to that in a minute. You can see that relative to our 20th century average, conditions were warmer than normal across most of the state. Near normal in the, I should say near average, because when I use the word normal, I want it to be with reference to the climate normals of 91 through 2020, near the 20th century average if we look at the southeast quadrant of the state. But then I said it was warm, and what I want to say here is that yes, it's warmer than the 20th century average, but it was the 3rd coolest June in the last 11 years. And I fully acknowledge that that is a cherry-picked time scale because I'm going back just far enough to include 2012, but it was actually cooler than the majority of Junes that we've seen over the last decade. And it, you know, if you extend that to the last 15 years, it would be the 7th coolest. So there would be a run of 4 Junes that were cooler than it from 2008 through 2011. But you know, if we kind of play the game of normal, new normal, not normal, I would say that June falls under the category of kind of new normal, where in recent years we are definitely used to Junes as warm as what we saw. It started with a couple days of cooler temperatures. We went into summer mode pretty fast, and then we actually had a little reprieve in that 4th week of June in terms of temperatures. Now we're looking at temperatures for the first 9 months of the water year, so October through June, again, the first 3 quarters of the water year. And you can see that we are well above the 20th century average for most of the state, and in most cases we're well above the last 30 years normal as well. And if we go back to this game of normal, new normal, or not normal, we get a mix here of new normal and not normal, where yeah, our baselines are shifted a little bit, but we started this water year kind of freakishly warm with a top 5 warmest November and December on record. And I believe you'll see that, yeah, on this slide here, where again, the first quarter of the water year was much above normal from a temperature standpoint. And then we really regressed to the mean from there. And again, June was warm relative to our whole 127-year time series, but given kind of the shifts in baselines that we've seen with more greenhouse gases in the atmosphere and just overall warmer conditions, it was kind of right in line with recent June conditions. So here's a time series of the first 3 quarters of the water year, or October through June. And yeah, you can see that over the last 10 years, we're tied for the 5th warmest. So right in that envelope of variability in terms of recent years, and 2.6 Fahrenheit warmer than the 20th century average. All right, so that's all I have for the month of June, kind of contextualizing that and where it falls in with the rest of the water year. Now we'll take a look at some more recent conditions. And we'll start with precipitation over the last 30 days, approximately. These graphics are just a couple days behind, and it'll be important to pay attention to those dates because some graphics are as much as a week behind. But you can see that we talked about how the monsoon season got off to an early start and a good start in that 4th week of June. And it has persisted into the month of July, with a lot of afternoon thunderstorms across the high country, particularly in southern Colorado, and even areas where it's kind of bled into the San Luis Valley with some decent thunderstorm activity. Although I did take a look at the Bregman Field Station, rather, in Alamosa, and even though it's been above normal over the last month and is above normal for the water year to date, the San Luis Valley is so dry that I think the precipitation total for the water year to date was still under 4 inches. Pretty crazy. But then you see, if we look at eastern Colorado, that we really see a mix where there's a few areas where we've had some intense thunderstorm activity leak out onto the plains on a couple of days that have made all the difference. But most of our thunderstorm activity has been terrain tied. So typically this time of year, yes, we can see that monsoonal moisture can, in some cases, help out eastern Colorado, but usually you need some sort of help or some sort of connection with like a mid-latitude weather system or a cold front that comes down from the north and links up with that moisture. And we haven't had any of that really to go around recently. So the storms have stayed fairly terrain tied, and you can see a lot of have-nots across the eastern plains, including the Denver metro area and areas immediately to the east. All right, here's a look at temperatures over the last 30 days. And this is not, these anomalies, or percentiles rather, are with respect to 1979 through 2015. So we're not looking at that baseline of the 20th century. We're looking at a more recent baseline. And we can see still above normal temperatures over the last 30 days. across a lot of eastern Colorado, but then in southwest Colorado, actually a little bit on the cooler side, where we've had better moisture totals. And those two things are related. So we've had monsoonal moisture in the area, which has kept humidity values up, which means when the sunshine beats down, the summer sunshine beats down on that area, it's really hard to keep the thunderstorms from developing. So we've also had more cloud cover, and that extra moisture just kind of puts a limit on how warm things can get, which makes a big difference this time of year. All right, now we're going to take a look at standardized precipitation indices across the state at several different time scales, starting with just the last 30 days. And here the warm colors are designed to fit the US Drought Monitor percentile classification scheme. So if they're yellow, that fits with the D0 range, or 20th to 30th percentile. Tan is 10th to 20th. Orange is 5th to 10th. And then if you're in the red or kind of dark red or burgundy, you're in the bottom 5 percentile. But we can see that the cool colors are the inverse of that, or wetter conditions. And over the last 30 days, much of western Colorado has been wetter than normal. So that's great to see. And certainly in the near term, helps keep the danger of fires down. So oftentimes when we have big fires, it's in our low snowpack years where we have a dry stretch after the snow melts in June going into July. And we didn't have that this year. And thankfully that's led to less fire activity, or certainly helped lead to less fire activity. So very good to see, but also, the summer moisture, it's not the same from a water supply standpoint. So more of it goes directly into the soils and then directly out through evaporation or transpiration, and less actually runs off into our lake streams and reservoirs. Okay, looking at the last 120 days, I mentioned that spring was dry across much of southwest Colorado, and you can see those really good wet SPIs that we had in the last 30 days disappear if we back out to the last 120 days. So we're balancing recent moisture against a little bit of medium-term dryness here. And then if we look at northeast Colorado, it's dry on dry, where it's been dry recently and a dry spring. And then if we look at the last 12 months, it's more dry on dry if we look at northeast Colorado, where a good example is Akron had its wettest spring on record, I believe, last spring. So March, April, May was wettest on record, straight into its driest summer on record. And we've stayed dry out on the Northeast Plains sort of since then. And so that's led to a number of struggles. And then if we look at the last 2 years, we can see dry conditions on average across most of the state. And I talked about this when we showed the time series of the first 3 quarters of the water year, but the 24-month SPI probably shows it even better. That yes, we have some areas of the state in south central Colorado where things have been near normal, but overall we're sort of slogging our way through these longer term drought conditions where we've seen less active wet weather to get excited about than would be expected climatologically. Okay, if we look at soil moisture, this is a map showing current soil moisture conditions, and it's actually a week behind. So like I said, it's important to keep track of these dates in case you're curious about how the last few days have affected things. And root zone soil moisture responds pretty quickly to wet conditions. So this map might not look as bad as you would expect, particularly the top 10 centimeters. So I'm not really showing the wet side here, but the dry side of the scale is shown in percent, where the color scheme again matches the US Drought Monitor's percentile classification scheme. And we can see a lot of the near surface soil has recovered with the wetter conditions recently across Colorado. But then if you look at the top meter, or a little deeper layer, kind of a root zone layer, you can still see dryness across a lot of the eastern plains. And if we had an even deeper layer, you would probably see these numbers look even worse, where you'd see more numbers probably below the 10th percentile. I should also say here that this comes from the North American Land Data Assimilation Systems NOAA model. Different soil moisture models based on their inputs and model physics vary, and they can vary quite markedly. I was looking recently at the grassroots soil moisture model, and it shows things quite a bit worse, particularly in Western Colorado. So conditions may vary depending on the product that you're using there. And then if we look at surface conditions in terms of vegetative health, we can also see dryness across most of the state, with some exceptions across the high country in the center of the state, where long-term conditions are a little bit better and recent conditions are wet. The northeast portion of the state looking the worst. So this comes from the Vegetation Drought Response Index, which is a satellite-driven product, and it uses what's called normalized difference vegetation index readings, which is basically looking at how well plant life is absorbing near infrared light. If plant life has plenty of water and is healthy, it'll absorb the near infrared really efficiently during photosynthesis, which is why it has that nice green color, but it absorbs that near infrared light less efficiently during dry conditions. And we can see that with satellite. And we see that throughout most of the state, we're showing moderate to severe drought conditions. Well, really pre-drought to severe drought. It really depends on where you're looking, but through most of the state, we're seeing dry conditions. And then another way we can look at surface balance is with, I'm sorry, was there a question on the line?
Hi, Peter, this is Tracy. Sorry to pause you. Do you mind going back to the vegetative map that you were showing before?
I can do that.
And I apologize if I've asked you this question before, but I just wonder how is this showing also our irrigated agriculture? And I guess if that's the case, I'm surprised to not see maybe more green in our heavily irrigated areas.
Yeah, sure. That's a great question. And I think that the reason you're not seeing more green is this is with respect to normal. So in the irrigated areas, you know, you might expect to see a little bit less of an anomaly, but I should also mention that while this product uses those satellite readings, it also is a blend that uses precipitation metrics like depiction. And I think that how some of those precipitation metrics that go into veg dry help to kind of control that difference in signal that you would see from just the satellite readings in irrigated versus unirrigated areas. But that's a really good question. Thanks for pausing me.
Okay.
Yeah.
All right. Thanks.
Yeah. So this is a look at our friend Eddie, or the Evaporative Demand Drought Index. And these, like the soil moisture, are about a week behind. And we're looking at the last month and the last 3 months. But this is showing the effective thirst of the atmosphere for water vapor, or if you have moisture in your soils, in your lakes, streams, and reservoirs, how fast is it going to get used based on not just temperatures, but also wind speeds, cloud cover, and surface humidity. And over the last month, we've seen below normal evaporative demand in areas where we've had good monsoonal moisture. And you know, precipitation doesn't directly affect evaporative demand. It's not part of that equation, but humidity both affects precipitation and evaporative demand. And with the monsoonal surge that we've seen some better surface humidity in the area. We've also seen better cloud cover as a result of those afternoon thunderstorms. We've seen lower temperatures as a result of those afternoon thunderstorms, and the wind speeds haven't been particularly high. So really every component of that evaporative demand drought index has been affected by the monsoon over the last month, and we've seen it lower on the southwest quadrant of the state, but out in the northeast portion of the state, high evaporative demand, where humidity maybe hasn't been as high relative to normal and conditions have been drier. Then if we look at the last 3 months, which at least includes part of our dry and windy April, we see higher than normal evaporative demand across most of the state, top 10 percentile across much of eastern Colorado. And then just one last way of looking at surface water balance before I get into the outlook is just looking at some of our longer term coagmet stations, looking at aridity percentiles or precipitation over potential ET. And we see that, you know, there's some kind of neutral news, not a lot of good news, a fair bit of bad news where we're looking at anything from record low or record high, I guess you'd call it, aridity, to near normal aridity values from our coagmet stations. I don't always show this graphic because we really want more long-term stations in the northwest portion of the state. So not great coverage in every area. We also have holes on the eastern plains, but just another way of looking at our water balance recently. All right, now I'll actually take a quick look at the US Drought Monitor. We can still see that drought persists across much of the western United States and has been growing across much of the southern United States. Here's a look at where we stand with Colorado on the US Drought Monitor. So some of our better areas have been over the center of the state, and then the southwest and northeast quadrant have been the driest areas. If we look at how things have changed over the last 4 weeks, we can see the influence of the monsoon in southern Colorado, but we can see some degradations northeast portion of the state. I would expect that unless there's a major change in the next couple of weeks, we're likely to see more degradations in the northeast just based on the dry conditions persisting as we've seen. All right, now we'll take a quick look at the outlook, and we'll start with the next 7 days. Then we'll go out to 8 to 14 days, and then we'll look at more of a seasonal time scale. So just looking at the next 7 days, you can see throughout much of the region, it looks like drier conditions are expected. If we look down in the southwest corner of this graphic, or the lower left corner of this graphic, you can see some continued above normal precipitation expected in Arizona, and that stretches into parts of Colorado. So again, this is monsoonal moisture. It's coming up from the Gulf of Mexico and eastern Pacific Ocean and getting kind of sucked into that thermal low that develops during monsoon season. And then with the hot conditions that we've seen, it's hard to keep thunderstorms from developing over the high country. We expect that to continue with some above normal moisture, likely in the San Juans and central Rockies, as well as areas like the South Park Valley. One thing I will say about this is that most of the moisture is stacked on the end of this time period, or kind of the 6 and 7 day time period. So there's time for this to change. We may see if that corridor of moisture shifts, it may end up affecting slightly different parts of the state. And then of course, this is going to be very convective or thunderstorm type moisture, which means that you'll definitely have haves and have-nots, where you're going to have areas where moisture is well above normal, and you're going to have areas maybe that are shaded in this blue-green that end up missing out. Also, we see below normal moisture likely to continue out on the eastern plains, as we just don't see much activity in terms of frontal passages. It doesn't take much to really get thunderstorms going this time of year, or really bring those out onto the plains. In terms of, you know, just a weak cold front will do it, but we're not seeing it. So thunderstorms will likely stay terrain tied. And then if we look at the 8 to 14 day time frame, it really is persistence being forecasted here, where we see a good monsoonal surge forecasted to continue throughout much of the desert Southwest that may affect southern or western Colorado. And then if we look at temperatures, we see the well above normal temperatures likely to persist as they have been over the center of the country, and that'll likely affect eastern Colorado. If we shift out to the seasonal time scale, I will say this is kind of an unfortunate time to have the Water Availability Task Force in terms of these graphics, because there will be new ones come Thursday morning. So do keep an eye on those. We'll have August through October seasonal forecast graphics from the Climate Prediction Center then. But for now, we're looking at a weak tilt towards above normal over Arizona from the monsoon, but they're not really extending that into Colorado. And then a bit of a stronger tilt towards below normal precipitation across eastern Colorado. And this is largely a land atmosphere feedback thing where we've been dry. Our soils are dry now, as we saw with the soil moisture graphics out east. And when you have dry soils this time of year, it means that when the hot summer sun beats down on the land surface, more of that energy goes directly into heating the surface, and less energy goes into evaporating or transpiring water through root systems, because the water is just not there. And if you're not doing that, then the humidity stays lower. You need that humidity to really drive thunderstorms. So it's kind of like Newton's second law, where an object in motion tends to stay in motion, an object at rest tends to stay at rest, unless acted upon by an outside force. A dry landmass tends to stay dry unless acted upon by an outside force. And of course, that does happen, particularly as we get into fall and the jet stream starts to get more active again. That could, of course, happen, but until we really get a good weather system to reverse things in eastern Colorado, that kind of drives this moderate tilt towards below normal precipitation in July, August, September. And then the above normal temperatures that we're seeing, the land atmospheric feedback that I mentioned also works on temperatures, but also a big part of that is just trend, where July, August, September has been one of the most consistently warmer seasons in recent years. And climate models do kind of show that that's somewhat expected in the future, is that the late summer and early fall is about the most consistent season in terms of a warming signal. In terms of what La Nina is going to do going forward into the fall and the next winter season, right now we're seeing that basically the message is El Nino is unlikely to develop this fall into winter. La Nina has a better than 50% chance of persisting into early to midwinter. And if it doesn't, it's likely to be neutral conditions. What does La Nina mean for fall? Well, this is just a look at whether we have elevated risks of cold or warm extremes and dry or wet extremes. On the left-hand side, if you have a blue, you have a greater risk of a cold extreme. A warm color is a greater risk of a warm extreme. So La Nina falls tend to be a little bit warmer. Although, again, I think the more important point to emphasize here is probably trend, at least in the early fall that we've just seen in recent years. It takes longer for the cold air to really stick around. We've seen some early cold snaps for sure, like in 2020 when we saw snow in just the second week of September, but the cold air is taking longer to stick around in recent years. And then in southeast Colorado, a little bit of an elevated risk of a dry extreme. I've also done some just correlation analyses looking at whether wetter or drier conditions are favored in fall based on what we've seen historically during La Nina. And overall, dry conditions are slightly favored. So between La Nina and trend, we have an elevated probability of a warmer than normal fall and a slightly elevated probability of a drier than normal fall. So just a couple quick takeaways, and then we will wrap this up. June was warmer than 20th century averages, but not out of line with recent years. Precipitation was a mixed bag, with the southwest portion of the state seeing some good precipitation from an early monsoonal surge, but a lack of rainfall over the eastern plains, particularly in northeast Colorado. Long-term drought remains evident in streams and vegetation. You'll definitely hear more about that from a water supply standpoint when I hand it off to Carl. An active monsoon season is expected to continue. There's at least a moderate tilt in the models towards that, but it's not clear that that'll affect all of Colorado. If anything, it looks more likely to continue to affect southwest Colorado, where we have a tilt towards drier than normal out on the eastern plains. And then with La Nina likely to be in play, but maybe the more important point is El Nino is unlikely to develop this fall and early winter, plus just the influence of climate change and trends, we're looking at an elevated probability of a warm fall and a slight tilt towards a higher chance of a dry fall than a wet fall, but that could certainly change. All right, I'll go ahead and leave things there. I'll stop my share, but if there's any questions or comments before we hand off to Carl, I can gladly field those.
I saw Megan had typed a question for you in the chat.
Yeah, the Landscape Evaporation Response Index, or Larry. Yeah, I'm familiar with it. I haven't used it in a couple years, but I don't know. Was there anything you wanted me to say about it in particular?
No, I was just wondering how you found it compared to some of the other evaporative, demand measures for Colorado.
We can chat about that a little bit more recently, but I haven't looked too much at Larry recently, so I want to kind of brush up on that and then get back with you.
Okay, no
Yeah.
worries. Thanks, Peter.
Mm-hmm.
I guess I'll just maybe ask a similar question. I recently saw this grassland productivity forecast.
Oh, was it Grasscast?
Yeah.
Yeah.
What?
So both Grasscast and Larry are looking at actual ET, and actual ET should pretty closely follow precipitation across our state, because we're in general a moisture limited state. I mean, there's parts of the high country where that's not necessarily true. But we basically use all the water we get, or our plants and crops use all the water they get, where that water is going to get transpired back through the plant's root systems. Whereas in an energy limited place like, say, Vermont, the amount of actual ET is going to be driven by basically how warm it gets or how much solar energy you have to facilitate transpiration, because they don't really run out of moisture.
It looks like Grasscast maybe only covers eastern Colorado also.
Yeah, and I know that there's been a lot of interest in Grasscast in the Southwest, and I know that they're working on that, but that's because the types of grass that you see in eastern Colorado and western Colorado or the Southwest are pretty distinctively different. I don't think I'm messing this up, but I believe it's eastern Colorado, you're more likely to be looking at warm season grasses, whereas Southwest, you're more likely to be looking at cool season grasses, where they're expected to be dormant during the kind of punishingly hot summer, but then grow during the cold season.
Okay, that's helpful. Thanks. Do we have any other questions for Peter? Okay, hearing none, turn it over to Carl in the NRCS. I see your presentation, Carl.
Okay, there. Sorry, I was
finding my mute button once I went into full screen presentation mode. All right, yeah, thank you, Peter. So I will kind of go through a fairly usual presentation, focusing a little bit more on some of the hydrologic conditions that have been going on in the mountains with respect to precipitation and soil moisture. Then obviously go through reservoir storage across the state. From the NRCS snow survey standpoint, it is an interesting time of year for providing as much information as we can, as we are nearing the end of our primary April through July water supply forecast season, as well as all of our SNOTEL sites have now melted out. But there's still a lot going on out there. And I also am going to touch base a little bit on some stream flow stuff, just qualitatively, look just at some individual points as we go through basin by basin. And then a bit of a big picture look at the end of what we observed in the April through June period. And then next month, once we have all of our full April through July stream flow values and all the stream flow adjustments for naturalized stream flow, we'll be able to kind of do a little bit more of a thorough roundup on how our primary snowmelt season has panned out. But I will just jump right in. There it goes. Starting up in Northwest Colorado. Here, looking at precipitation, kind of north central and northwest Colorado. Again, all of the data I'm referring to here is from SNOTEL sites, so in the mountains, whereas a lot of Peter's data kind of includes valley stations as well. But up in Northwest Colorado, had one of the more kind of consistently near normal precipitation trends throughout the year, currently residing just slightly below normal at 98% of the median. And again, and Peter touched on this, but as we have recently switched to the new normals, as we call them, anytime I use that term, I am referring to comparing to the 1991 to 2020 time period. And for the NRCS, we did also switch all of our normals to be consistently referring to the median as opposed to the average, where during the last normals period, we were only using the median for snowpack. We are now using the median for precipitation, reservoirs, and stream flow as well. So over just to the east in the Laramie and North Platte basins, slightly improved precipitation throughout the water year, currently residing at 103% of normal. And I will just make one other note as we're going through all these. This month, you will see some little kind of inexplicable blips in our precipitation graphs. And that is due to, we've just got crews running around all over the state doing our summer SNOTEL maintenance. And we just need to do a little bit of back end work on our database side to clean up some of this data, but it should still be painting a pretty accurate picture overall. So looking spatially here, both site by site as well as whole basins, all of these maps for the basins are looking at our month to date, so July 1st through the 17th. And as has been touched on, been a very productive monsoon season so far, and most particularly in the mountains, as generally happens with these convective storms. You'll also notice with the nature of those convective storms, just being really, really localized with, some sites still receiving below normal precipitation, some well above, here up to several up over 400% of normal, but throughout the basin, well over twice the normal precipitation over the last 3 weeks or so in the mountains of Northwest Colorado. Looking at soil moisture conditions at SNOTEL sites, can see going into winter last year, throughout most of the winter, soil moisture conditions were holding at above normal values. And really following a pretty normal temporal pattern with that, you can see kind of the initiation of snowmelt here towards the very end of March, presumably mostly at lower elevation sites. And then once much more of the snow started to melt out, a lot of those drying out, but still leaving soil moisture conditions at above normal values up in the mountains. Fortunately, I'm not sure I have to touch base with one of our other hydrologists. We're missing some of this reservoir data, really not much for volumetric storage in the Yampa White. But here Yamcolo is just below 50% of the median storage currently. So in lieu of the full basin by basin roundup of our observed stream flow, as well as I haven't included the forecasts since we're now 11 days out from the end of our primary forecast period, but I wanted to put some of these just time series graphs in looking at observed stream flow at some of the more major pour points in all of our major basins to at least get a qualitative idea of what was going on. And there is really, especially as we go to other parts of the state, some interesting stuff going on here. But total, you can get a decent qualitative idea. Definitely looking at below normal volumes so far throughout this snowmelt runoff period. One thing to kind of pay attention to is you can kind of see here the Yampa at Maybell, just as of recently, this hydrograph has kind of flattened out as we are nearing that primary snowmelt portion of the hydrograph and getting closer and closer to standard base flows. And we'll see that shift quite a bit earlier, even in our southern basins as we get there. But throughout the spring season, there's ups and downs with temperature, precipitation as snow, precipitation as rain. You can see some of these more recent bumps from the monsoon moisture, but again, per usual, those signals are a lot stronger in southern Colorado. So moving down into the Colorado River Basin, very similar precipitation pattern throughout the water year overall, just slightly higher than the Yampa White and Little Snake, slightly lower than the Laramie and North Platte, currently sitting at 101% of median for the water year. Going to our map, looking at all the different stations. Again, slightly less than the previous basin, but still very, very near twice the normal July to date precipitation in the Colorado headwaters. With just the same thing, a lot of spatial variability site by site with those really localized and powerful convective thunderstorms, but really, really great to see this moisture coming in. And as so far without any associated lightning causing major wildfires. So hopefully this will continue to wet up the basins and help prevent that going forward as well. Looking at soil moisture, bit of a different pattern here. You can see throughout the fall and throughout most of the winter, was holding below normal soil moisture values. But then really, really big boosts here throughout the snowmelt season. And then also you can see a bit more as more southern, or not southern Colorado's stations, but stations further south than we saw in the Yampa and White, a bit more of an increase in soil moisture from the recent precipitation we've had. So soil moisture is, believe that's in the range of like the 70th percentile. So sitting pretty dang good as far as soil moisture is concerned currently in the Colorado Basin. Looking at reservoirs, I believe the Colorado currently has the best reservoir storage in the state. Colorado and the South Platte are definitely the two highest. So here's just kind of a snapshot. It looks like Williams Fork is right near the normal value, 100% of median. Lake Grande is higher. A lot of these other kind of major reservoirs are lower, but still sitting better than most other basins in the state. Looking at our time series plot, again, some good news with respect to this water year. You can kind of see after the kind of boost here in 2019, Kind of a consistent drop for a couple of years, but reservoir storage has been pretty steadily recovering throughout water year 2022, closer and closer to the normal value. So here's our hydrograph for the Colorado River at Cameo, pretty far west in the state there. Temporally, pretty similar pattern to the Yampa and White, with throughout the kind of late spring, early summer season, lots of big ups and downs. One kind of last major increase here, and then kind of steadily declining. And again, I will also plug that these hydrographs can vary depending on how they paint the picture of the whole water supply situation, because these aren't necessarily accounting for changes in upstream reservoir storage. And that is some of the data we'll be able to present next month is looking at our naturalized total volumes that we've observed, accounting for those changes in reservoir storage. But mostly through the declining limb of the hydrograph here, you can see it is really holding it pretty well below normal values. And time will tell, but based on this basin and particularly a lot of what we're seeing in southern Colorado, would anticipate base flows to continue to level out at below normal values as well. And one other just quick note, I'll probably point this out again when we get down into the southwest basins, but for those who aren't as familiar with these hydrographs, note that they are on a log scale here. So, you know, as these lines all delineate 1,000 CFS, but as they get closer and closer together, then they represent basically more water. So, you know, this, depending on how big your screen is, and an inch of increase in this portion is going to be a lot more cubic feet per second than an increase down here in the lower end of the log scale. So moving over into the South Platte Basin, resulting from the Northern Front Range. Definitely pretty plentiful water year to date precipitation so far, currently residing at 105% of the median. Fairly steady, kind of up and down, but generally surrounding that normal line, which is the green line in all of these throughout the water year. But since about our last meeting in late June, some more steady precipitation has brought it back up above the normal value for the water year. Again, kind of as anticipated, these being the furthest northeast mountainous regions within Colorado, hasn't gotten quite as much benefit from the monsoon moisture that further southwest gets, but still above that median value for July to date at 133% of normal. And also, as we see with all the basins, just station to station, highly variable, as is the nature of these convective storms in the mountains. Looking at soil moisture here, similar pattern in a general sense compared to the Colorado, but you can see going in fall and throughout the winter season, soil moisture was even quite a bit lower relative to normal. Here down in range of the lowest 10th percentile of soil moisture, but temporally tracking at a pretty normal values, along with a more normally timed snowmelt than we saw in other parts of the state. But also here trailing back recently down into that lowest 10th percentile, with the South Platte not receiving quite as much of the recent precipitation as some of the other mountainous regions. As I mentioned, in combination with the Colorado, the South Platte is also in range of some of the highest reservoir storages in the state. You can see there's a fair number here that are in fact above the normal value, above 100% of median. Some definitely that jump out as quite a bit lower, but relatively consistently, a lot of these are in the 90 to 100% of the median range, which is good to see. Looking at our time series here, this one is kind of opposite of the Colorado. How you can see throughout this water year, it has been a decline in that net storage within the South Platte Basin, but that is following a good time period of it being the only basin in the state that was holding above normal reservoir storages. So still not too bad. And I'll have those, I believe it's currently 92% of normal, and the Colorado Basin wide might have been 98, but I will have that exact information at the end. So moving back to the western slope in the Gunnison River Basin. Water year to date precipitation, again, not too bad, a bit lower than some of the other ones we've been looking at, but currently holding at 96% of the median. And again, some of these numbers will change slightly as we go back and do some of our back end database work, following up on field work, but still within range of the normal value, which is good to see. Looking station by station, month to date precipitation in the Gunnison is 142% of the median. Again, not a ton of big north to south trends here, more just localized station by station differences. But just with the dryness we've seen over the last several years, especially, and particularly hot and dry summers, this is all very welcomed precipitation to this region. Looking at soil moisture, I don't believe I included the Gunnison soil moisture last month, but you can see going into winter here was pretty stark. This, I believe this red shading is the 10th percentile, and the red solid line is our minimum observed. So we did go into winter and maintained throughout all of winter quite a bit below. So this is next year, this is going to be our new lowest observed soil moisture values, but really a huge jump right when we started to see signs of snowmelt there at the beginning of April, with ups and downs over the last couple months. And then you can see as we move farther southwest in the state to areas that have received a bit more of that monsoon precipitation, some more increases in that soil moisture back up to well above normal levels. Really started getting back above normal near the beginning of July, but with those increases near during the end of June. Reservoir storage is a lot less plentiful in the Gunnison and our southwest combined basins, as we'll see here. Looks like Crystal down is one of the two below Blue Mesa, is really the only major one in the Gunnison holding above normal values. Paonia is pretty close to that value. Then we've got Blue Mesa, the biggest in the state, looks to be a little bit above 50% of the median value currently, but encouragingly has shown some increases. Because I could have put some more graphs in here. There was something quirky going on with our basin-wide time series that I need to look into, but I did include this time series for Blue Mesa, where you can see it has gained quite a bit of storage. Looks like from about 240,000 acre feet up to about 390,000 acre feet during that primary snowmelt season, and then kind of tailed off just over the last couple weeks. But obviously the flip side of that is they were releasing absolutely minimum flows down below Blue Mesa to try and boost that storage, which I can only assume would have a notable impact on downstream water users for this season. So looking at our major pour point for the Gunnison Basin here at Grand Junction, getting into definitely some more interesting trends that we'll see consistently across Southwest Colorado here. So, you know, some big peaks early with a really warm, dry spring. Really saw some early snow melt. Then a lot of ups and downs with fluctuations in mountain temperatures primarily. Big drop here, but you can really see there's a volumetrically, we're gonna, once that data all comes to light, really looking at well below total normal volumes for the Gunnison Basin here. Again, this is about 2,000, 2,500, about maybe a 3,500 CFS per day deficit for quite a bit of this time period. And as we get down closer to base flows, down about 800 to 900 CFS currently, when it usually be about 1,800. And I'll be pointing this out throughout the next couple basins. And it follows up on a great question we had last month about the impact of monsoonal moisture on stream flows, and more specifically on how that affects the total volumetric values that we're seeing. You can see these big pulses and stream flow increases from major precipitation events, but they really do come back to the base flow values pretty quickly after those events. So definitely helps the entire hydrologic system and that much more water in the river, but doesn't really do a ton to the total seasonal volume as compared to the primary snowmelt pulse. Going down into our combined San Miguel, Dolores, Animas, and San Juan basins. A bit drier on the water year-to-date precipitation front, currently at 92% of the median. But here it really jumps out. You can see since late June, kind of mid to late June here, this consistent increase in mountain precipitation resulting from some of the monsoonal weather is very welcomed after basically 2.5 months or so of very dry weather. So that is great to see down in Southwest Colorado. Basin wide, that has left these combined basins at 160% of the median July to date precipitation. Again, a lot of variability station by station, ranging from 60% here at Lone Cone, I believe, up to 350%. I believe that's probably El Diente here close to Lizard Head Pass. Looking at soil moisture, was holding going fall into winter and throughout winter, was holding below normal soil moisture values, but actually quite a bit better than several other of the basins we've looked at. Again, and also following a relatively normal temporal curve, just a slight increase during snowmelt here, but again, just as it dips down into the bottom 10th percentile, you can see a considerable increase from the recent precipitation over the last 3 to 4 weeks. Looking at reservoir conditions, believe the Gunnison and these combined Southwest basins are the two that are holding the lowest total reservoir storage, or excuse me, relative to normal, the lowest reservoir storage in the state, not total volume. But most of these, all of these currently at below 85% of the median storage, some quite a bit lower than that. Here in our time series graph, again, these really do a great job of painting the picture of how multi-year drought really does impact our total water supply system across the state. We can see with the increase, this is kind of spring, summer, fall of 2019 after that enormous snowpack, and has really been in a steady decline since then, where you see these little cluster of dots. That would usually be the snowmelt runoff increase year to year, but throughout the last 3 years, really, we've only seen it briefly, reservoir storage, and this is referring to total volume, briefly flatten out and then decline, briefly flatten out and decline. And again, the same thing this year, looking at steady declines, which puts us at some of the lower values we've seen since 1990, with those considerable drought periods in the early 2000s and around 2012. So definitely something to keep a very close eye on in Southwest Colorado. So I think this is a an interesting hydrograph, and I've got a couple for these basins, painting kind of the picture of the impact of both the earlier than normal observed snowmelt, and then also the impact from monsoonal storms here in the San Juan Basin. But you can see generally the animus at Durango would peak around the second week in June. It was in the range of about a month early this year with those earlier than normal snowmelts. Presumably this is a period of colder weather is driving it back down. Some diurnal fluctuations from snowmelt pulses, but here you can really see these rather dramatic spikes from the bigger periods of monsoonal moisture. But again, as I previously mentioned, this is kind of the poster child of how these types of storms, once primary snowmelt season has waned, can cause a big pulse in stream flow, but it generally drops right back down to base flow levels pretty quickly. But regardless, still great to see the water getting into the soils, getting into the system, getting into the rivers, no matter what. But again, as we are getting closer and closer to the hydrograph leveling out to base flows, worth noting the difference between the normal value and observed currently. So likely to be seeing below normal base flows as well, but we will just wait and see with that, because there still are quite a few factors that can influence it. Similar thing, I put the San Juan at Pagosa in here. And this was a good example. This is a bit different than what I was describing with, kind of immediate drops back to base flow, but it could be due to kind of closer timing of the precipitation events. But definitely some sustained higher values for about a month here, and have then kind of been steadily dropping back down. But again, with these spikes, keep in mind the logarithmic scale on these graphs. So, an increase of an inch on your screen here is substantially less water than an increase of an inch on your screen here. So some great increases to see, but we can see just really driven by individual precipitation events or periods of precipitation, and then kind of declining back down. This one I just put in the last minute. It should have been in the Gunnison Basin. My apologies for that. I can get that switched up. But I kind of wanted to highlight the differences in geography here. I wanted to just put something coming out of the northern San Juans, where you can really see so much more of a pronounced difference from the monsoonal weather in those last two southern San Juan rivers compared to a northern one, where here in the Uncompahgre we're seeing the spikes, but not quite as dramatic. Over into the Rio Grande, water year to date precipitation is currently at 93% of normal, but can see really great increases, a lot of precipitation gains since the last week and a half or so of June there. Kind of flattened out a bit lately, but really great to see the mountain precipitation in the Rio Grande. Looking at the basin as a whole on the map, that is accounted for 186% of median July to date precipitation. A little bit more consistently high than a lot of our stations, but still some local variability there as well. So looking at our soil moisture in the upper Rio Grande, some pretty interesting stuff going on through here. Throughout much of winter was kind of on the edge of that 30th percentile down to flirting with the 10th percentile soil moisture. Back up briefly close to normal with the first pulse of snow melt. And then here we can really see this big boost with the monsoonal moisture, bringing that soil moisture back up above the normal value where it currently resides. Reservoir conditions, we've got a handful of decent sized reservoirs holding above normal storage. So basin wide doing a bit better than the last two basins we looked at, not quite as good as the Colorado and South Platte. Going to our time series here, definitely not as consistent of a decline as in the combined San Miguel, Dolores, Animas, San Juan, but holding generally below normal values for the last couple years since that last big spike in 2019, resulting from that significant snowpack. So here's our stream flow for the Rio Grande at Del Norte. Very important stream flow point for our Rio Grande compact. I know it's been a very challenging management situation for the folks down there, as I have heard, but we did, I'm sure this has been mentioned in many of the meetings, but we did observe the fastest snow melt rates on record this year in the Rio Grande, which is what's driving this extremely early stream flow peak. The warm, dry weather combined with dust on snow really melted the snowpack extremely quickly, leading to this peak stream flow at the Rio Grande at Del Norte just about a month earlier than normal. And I've seen some small increases from the monsoonal weather, but more or less getting close to base flow levels within the time frame of when it would normally just be peaking. So on to our final major basin over in the Arkansas. Currently very near normal water year-to-date precipitation at 101% of the median. Very similar pattern that we've been seeing with the increase in precipitation starting in late June here, bringing it back to those above normal values. And similarly, not a ton of obvious spatial patterns here. With those convective storms, it looks like we've got, so maybe Trinchera, snowtel over 500%. Looks like this is, I think, Grayback snowtel, 500% of normal July to date precipitation. And then quite a few even up in the headwaters doing quite well, leaving that basin at 181% of the median July to date precip. All major reservoirs, at least that we've got displayed on this. Again, this obviously isn't all the reservoirs in the basin, just kind of a handful of them, but all displaying below the median storage for July 1st. Similar to the Rio Grande, looking at the last 3 or so years since 2019, not the consistent drops we saw on the far southwest portion of the state, but also haven't really observed notable increases in the storage with our snowmelt runoff. Kind of a lot of up and down, but residing generally in that below normal range for the last couple of years. So I chose, just kind of picked one. Arkansas at Parkdale is in between Salida and Pueblo. And again, the Arkansas does get a fair amount of water managed from Turquoise Lake, so not a completely natural system, you know, obviously as well as other management in the system, but slightly earlier than normal peak flow timing here, is then it's kind of dropped off and paralleled on the declining limb, paralleled the normal values, which is also a median here for the USGS at about maybe 500 or so, bit more than that CFS, less than the normal value. So statewide, mountain precipitation since October 1st of 2021, pretty much right at the normal value, 99% of the median, which is great to see. And we've touched on this quite a bit. We've heard a ton about it the last several years with hot, dry summers, the low soil moisture conditions really contributing to runoff efficiency. And by contributing, I mean harming the runoff efficiency with snow, not as much of the snow melt making it to the stream channels as we commonly see. So this isn't really reflecting the stream flows we've been observing, but still encouraging to see the near normal water year-to-date precipitation across all of the major mountainous basins of Colorado. So here's a statewide look at our month-to-date precipitation. With South Platte receiving the lowest values, followed by the Gunnison, and then all the other major basins in the state ranging from 160% of normal up to over 200% of normal in far northwest Colorado. And again, with reference to the normal values, I'd have to take another look, or I'm sure Peter would have some more insight in this, but it is also worth bearing in mind that it might not be reflecting the quantity or the total depth of precipitation received, because it is common for the Southwest basins to receive a stronger signal from the monsoon. But all the nitpicking aside, really great to see this precipitation, and this actually bleeds over into the last couple weeks of June as well. So really great to see quite above normal precipitation values across the state. Looking at our water year to date precipitation, really fairly closely clustered, more than we've seen in the last couple of years, ranging just from a low of 93% of median down in Southwest Colorado up to a high of 103% in the Laramie and North Platte. Going into reservoir storage, again, apologies, we're missing some data here in the Yampa White Basin. Not a ton of total volumetric storage up there, but I believe this is based on just the Yam Colo value. Some of our lowest values down here in the Gunnison and combined Southwest basins at just 64% of median storage. Highs in the Colorado just barely below normal values, followed by the South Platte, and then the Upper Rio Grande and Arkansas kind of sitting it right in the middle of the range statewide with respect to reservoir storage. Here, looking at our time series, we've got all, and again, this is a volumetric measure. We kind of go back and forth between the volumetric anomaly and the percent of normal. But we've kind of got this lighter brown, beige, tan color here is the statewide total. And then all the other ones are basin by basin. So we can kind of see what's contributing here. This darker brown is our combined San Miguel, Dolores, Animas, San Juan, followed by the Gunnison, that are the two biggest contributors to that deficit, and then kind of the other basins there. But in the big picture statewide, we can just see that giant increase from the pretty banner 2019 snowpack season, and then really steadily declining since then. So I didn't go through this basin by basin because, as mentioned, can be a bit of a process compiling all of our adjusted stream flows. And for those that aren't familiar, we call them adjusted or naturalized stream flows. So a lot of what we present and what we base our stream flow forecasts on are doing our best to account for management in the system, basically changes in reservoir storage, diversions within basin, trans-basin diversions. So some of these major data points aren't on here, but in a broad stroke does paint a pretty good picture of what we have observed for stream flow in the April through June period. And these are the adjusted values. And then we'll have the full April, July period available next month. But you can kind of see, obviously we've got the basin-wide numbers here in bold, with some of the lowest being down here in the Southwest Colorado. I'm anticipating this number to be quite a bit higher. I know the forecasts for the upper main stem South Platte here were quite a bit lower than the rest of the Northern Front Range, which we rely on external sources to provide natural estimates for these. So hopefully we'll have some more data for that. But even you can kind of see throughout this kind of bottom third of Colorado, a pretty distinct line where the Gunnison Basin as a whole is reporting 81% of normal April-June stream flow, but a pretty stark line here of things coming out of the northern San Juans versus things in the more northern portion of the basin coming from the mountains more out of central Colorado, coming out of the Elks, West Elks, Grand Mesa, areas like that. Statewide soil moisture, again, I'm sure everyone's very well aware when we're looking at these statewide numbers. In Colorado, it really matters what primary basin of interest you are concerned with. But good to see, starting with the primary snowmelt season and then some more increases with the monsoon weather. Briefly hit normal statewide soil moisture values at our mountain snow-tell stations, and a bit below, but not sitting too terribly compared to what we've seen in years past. So just a quick summary here. Again, I think we've pretty solidly beaten it to death by now, but really seen substantial precipitation coming from early monsoon season, late June through present, which has been awesome to see, bringing well above normal precipitation across all of the mountainous regions of the state. All major basins are currently holding below normal reservoir storage, with the lowest being in the Gunnison and our combined Southwest basins, the Colorado Basin and the South Platte, both holding in the 93 to 98% of normal reservoir storage. Really saw some incredibly different timing scenarios with respect to snowmelt runoff, with the Rio Grande and our Southwest Basin seeing up to a month earlier than normal snowmelt runoff, both observed at the snow-tell stations, as well as the resulting runoff in the streams. And then quite a bit of variability from there across the state, depending on spring weather, on into the summer weather and into this monsoon season. Also note, touched on this with a few basins, is really great to see the monsoon weather come through, really bring a lot of moisture across the mountains of the state, which has caused some significant spikes in stream flow in some areas, but those aren't necessarily going to contribute an enormous amount to total seasonal volume. Things that could really cause a substantial increase in reservoir storage. But these rains are really bringing a lot of water into the basins, into the hydrologic system as a whole, boosting the soil moisture is hugely beneficial, especially if that's able to maintain going into next winter. And we are, again, getting, depending on basin and the timing of this year's runoff, closer and closer to that more stable base flow, which will carry us through the late summer, fall, winter until we see snow melt next year. That is all I have, and I'm happy to take any questions.
Any questions for Carl?
I'm seeing one from Peter. Hopefully we'll be able to get that data. We'll have to reach out to them. But commonly it does take a little bit after the April-July period to get those stream flow estimates for a lot of those northern Colorado from, what am I thinking here? Like definitely Big Thompson, maybe Boulder, but definitely like Big Thompson, St. Vrain, Poudre. We do rely on Northern Water and other, mostly from Northern Water to get those. So hopefully by next month's meeting after the end of July period, we will have some of that data. But that will make the basin-wide number more cheery, because we've been seeing those upper main stem forecasts and conditions be much drier than the northern front range.
Yeah, thanks, Carl.
Yep.
Any other questions for Carl? Thank you, Carl. I did put in the chat my plan for just going through our report outs. I want to quickly turn it over to Rob Harris, and I need to jump off to another meeting. So go ahead, please, Rob.
Great. Yeah, I'll just drop this link in the chat to our fishing closures list. We've had a whole bunch of new closures that are primarily heat related, and that issue is exacerbated by flow. But these are fishing closures. I note that only one of them is mandatory. This is 0.6 miles downstream of Stagecoach. The rest are all voluntary, but reflect, yeah, just the high temperatures. I mean, just as an example, I gathered that a temperature close to 76 degrees was recorded at the Colorado River at Hot Sulphur Springs recently.
The water temperature?
The water temperature, yeah. So
does that have anything to do with the natural heat in that area, or is it simply the low flows?
My understanding is that and it's possible that is the highest number, but it's not actually that anomalous compared to other spots on the river, you know, which were more than 74 or 75, I think. So, so quite warm, yeah. So, and I would note that, yeah, several of these just cropped up in the last week, and I wouldn't be at all surprised to see more. So stay tuned, and I apologize that I can't stay any longer, but I have to jump on another call.
Can I ask you one last question?
Sure.
Are the number and the timing of the fishing closures, is this unusual in recent years?
I would say last year looked a lot like this, but I think last year was a little bit unusual for the prior couple of years. So yeah, and I'd have to ask our bios to get a more complete view of that. But yeah, I think, yeah, it's certainly been a warm couple of years.
All right, well, thank you, Rob.
Great, thanks, Tracy. Thanks, everyone. Bye.
All right, next up, Kevin Hauk from CWCB.
Thanks, Tracy. Just a few comments that I want to offer up. It seems like in recent years, whenever we have our July meeting, it's always mired in how hot and dry it is, and this year is kind of like that as well. But this is always the meeting that I pay the most attention to, because it seems like if you look at Colorado flood history, it always seems to peak right around August 1st and the week before and after. So my birthday is this Friday. I always celebrate my birthday and then always worry for the next 2 weeks about flood events. We just had one actually last Friday. I think many of you have read about that in the news, and it just further underscores that even in the middle of very dry conditions, we can have deadly flood events, especially around burn scars. This one made me particularly sad because it was a very well forecasted event by all forecasters, and yet it still happens. So I just invite everybody to be very safe in the coming weeks. Indeed, our own flood threat bulletin, which offers a twice weekly flood outlook, does show some elevated risks starting on Saturday, I believe, and going through the middle of next week. And this is the time of year, like I said, when I watch everything very, very carefully. The heat, of course, is also another thing I've been watching very closely. I don't know if anybody mentioned it, but looking at Denver only, because that's the area that I seem to have the most access to statistics. But if the month were to have ended yesterday, this would have been the second warmest month in Denver history, behind only July of 2012. And looks like it's going to continue to be hot through at least Saturday before things cool off a little bit. So I'd love to hear what Peter might have to say, but I think this might end up being the warmest month in Denver history. And I'd be curious to see how everything shakes up when looking at the state as a whole. I think that's about all I wanted to say, but just be safe out there. Remember that floods can occur even in dry weather, and we are approaching the peak of the flood season in the next couple weeks. Thanks for giving me a couple minutes, Tracy.
Thank you, Kevin. I haven't seen Peter unmute to see if he has any comments about your prediction there, Kevin. All right,
I'll have to
well,
look closer. I don't have anything to add to what Kevin said, but I'll have to look closer to see if I agree about it being likely to be the hottest on record.
yeah, we'll see. All right, so just going down the list that I put in the chat, Kristen, are you still with us from the Department of Agriculture? And I guess if I don't, I think she's left. So Robert Sakata, hopefully you'll just let me put you on the spot here.
You bet. Thanks, Tracy. It is very hot on the farm. You know, most of our ditches are in sections, which we expect this time of year, at least for growing crops. The main thing is ET rates are really high right now with the extreme temperatures that are going on. And I think at least in eastern Colorado, I think too, the farmers that I've talked to that have animals are having grazing issues just because there just wasn't a lot of moisture in the spring for the grasses. So they're actually already having to try to get some feed and stuff. The one advantage that we've seen so far, especially I attribute it to the fact that we've stopped growing onions, is that we haven't seen the hailstorms that we normally do this time of year. Of course, we haven't got the precipitation. That's what we've always argued about, is that as farmers, we almost hate to wish for precipitation this time of year because it's either flooding like Kevin has just mentioned, or we get it in hail, which is totally devastating. So we haven't seen that this season. So I'm talking to a lot of the vegetable farmers in the area. They've been happy with that fact. So thanks, Tracy.
So you stopped growing onions, which made it not hail. Is that what you're saying?
Yeah, exactly. That's what the old adage is they say the best way to avoid hail is not grow onions or not grow a crop next to a farmer that does grow onions. So
good to know with many vegetable farmers. Thank you.
yeah.
All right, next on the list, I had Beverly from Upper Gunnison.
Hi, I really don't have a whole lot more to report other than what Peter and Carl both said. We are still in the middle of the monsoons. It is raining just about every afternoon. It is greening things up, so it looks very green up here, but the stream flows are all at all gauges up here are well below normal. We see the little pulse, but as they said, it's returning to the base flow pretty quickly. So.
Okay, thank you. And next up, Karen from Telluride. You still with us? We might have lost Karen. Okay, I will move on to, I saw we had a water demand representative from Eagle River. Hi there, Ray.
Oh, hi. I'm just an intern. It's my third week on the job. So I'm just here to hear some conversation and learn some vocabulary.
Okay.
I'm getting that and I really appreciate it. I live up here on Tennessee Pass and there are a lot of mosquitoes and a lot of wildfires. So
I've been wondering, are mosquitoes an indicator of good moisture conditions?
they appear to be quite happy right now and this entire spring. It's thick.
Yeah. All right. Well, thank you for joining us.
Thanks.
I saw that we have someone online from the Roaring Fork Conservancy. I just thought I would ask if you had anything to add from your neck of the woods.
No, not too much to add. I think we're seeing similar to everybody else where we've got generally low stream flows, but we are seeing afternoon clouds and storms. Quite a bit of lightning too.
Okay. Well, thank you. Next up, Bill Tyner, our division engineer from the Arkansas River Basin.
Good morning. In the Arkansas Basin, I think one thing that makes conditions here a little bit confusing is that reservoir storage wise, our municipalities have learned good lessons from hard times prior to this, especially the 2002-2003 drought period and the 2012-2013 drought period. So reservoir storage tends to be a little higher because of municipalities hanging on to water supplies and trying to manage them very effectively. The story's not so great for agricultural supplies. Particularly notable would be John Martin Reservoir, our largest reservoir, where we're just down under 18,000 acre feet of storage in the reservoir, and that includes the permanent fishery pool and some accounts that would not normally be released for irrigation. So stored supplies are pretty critically low, and we've benefited a little bit from monsoon precipitation, but we've started to see that drop off pretty significantly. So we're hopeful there'll be one more shot, but I would expect, as I've looked back on data, that this particular 3-year period, 2020, 2021, and 2022, each year being successively worse for agricultural water supply from Pueblo down to the state line where most of our agriculture exists, it will end up being not quite as bad of a 3-year period as the worst period in 2002 through 2004, and actually not quite as bad as in 1976 through 78. But it will, I think, be worse than the 2012 through 2014 period. So it will be one of our worst 3-year periods in the Arkansas Basin. And we hope for a return to better, wetter times, but ditches with more junior water rights have suffered a lot this year. They have had to rely mostly on stored water and have not had much of an irrigation supply. So been a tough year on those ditches with more junior water rights. Thanks, Tracy.
Thank you, Bill. Next up, Emily, Northern Water.
Hi, good morning. First, I just wanted to comment quick on the South Platte numbers. I just sent them on Friday, so they should be updated pretty soon. Those are pretty, fairly rough estimates because there's some diversion data that is delayed for our calculation of undepleted flows in those basins. But it looks like for the Poudre is around just a little bit above average, 102% of average. Big Thompson was around 95% of average. I would expect those to decrease a little bit because the flows have kind of dropped a bit below average generally recently. So I expect those final percentages for April through July to be a little bit lower than that. And then for the St. Vrain and Boulder Creek, those are rougher estimates. So I'm not going to give an exact number right now, but it's we generally saw those to be drier, a bit drier than the Big Thompson and the Pooter. But yeah, those should be available soon, I think. And then for Northern Water, we did get very close to filling Grande. And part of that was because we had lower forecasts for Upper Colorado and Willow Creek at the beginning of the season. So we thought we had more space to put some Windy Gap water in there. And also because of some operational things with reclamation. So due to a combination of factors, we got very close to filling Grande. But in our service area, it's been very dry. June precipitation was like 30% of average, I believe. We didn't get any East Slope priority. We have junior priority rights on the East Slope, and we didn't get those this year because the call was on for the whole time. But yeah, that's about it.
All right. Thank you. All right. I know we have a number of Front Range water providers on, and so I didn't list you all one by one. So then I see your face. So maybe bring your face back. So yeah, if you would kick it off, that'd be great.
So here in northwestern Douglas County, Highlands Ranch, our reservoir storage is at 37% of capacity. That's about 20% lower than we usually are in the summer for this time of summer. Our demands were elevated in June, about 13% above what we projected. So far in July, they're 11% above what's projected. And really the reason I jumped on is just to let you know, Tracy and Megan, that Centennial a couple weeks ago declared stage 1 drought measures. Those go into effect tomorrow, the 20th. That is the first level of mandatory restrictions for water conservation, for water use reduction, primarily targeted at outdoor use. So we're asking people to get a 15 to 20, to reduce their water use by 15 to 20%. It is mandatory no more than 2 days a week of irrigation, outdoor water use. Any water features like splash pads, water fountains like that are now prohibited to be in operation. We'll see how this goes, and there's a good likelihood we will, at the end of the month, may well implement increased drought pricing for drought rates.
At the end of July.
Well, our board could, if they vote to go that would be the last week of July, and I think they would be effective 1st of August. That's all pending. That's just a possibility.
So then is this typical of this time of year?
No. So we are having, like I say, our reservoir is probably 20% lower than what we normally are this year, and with the elevated demands, we really were not able to get a normal amount of water off the river this year due to the, as Peter and Carl showed, the low soil moisture in the South Platte Basin, the warmer temperatures, and as Emily mentioned, the senior water rate calls, particularly on the South Platte Basin. The 1871 call has really impacted our ability to get water from our rights in South Park. So we're just very concerned at this point and taking action to make sure it doesn't get worse than very concerned.
All right. Thank you. So could I have some other Front Range water providers. Jordan, I see
I can
you.
jump in. Yep, this is Jordan Soldano from Denver Water. So right now our reservoirs are 91% full, and normal for this time of year is about 96% full. Our recent summer demands have been about 10% above normal, and we just attribute that to the hot and dry weather. As of now, we just have our normal watering rules in effect, 3 days a week and not between 10 and 6.
I think I saw some of your social media folks post that your system did not fill this year, and so they were asking folks to conserve. Seems sort of like a voluntary ask at this point.
Yeah, I think at this point, we're really just focused on kind of that conservation messaging.
Okay, thank you. John, how about you?
Cool, I'm here.
John's
Let's see.
important.
Oops, something jumped in front. Okay, demand year to date is 12.06% above 2021, which is actually coming down a little bit. And we were very high during the dry April and May when people started irrigating outdoors. So reservoir storage is sitting at 37,516 acre feet, which is about 96.9% of average, and that's pretty usual for this time of year. And the senior calls so far did not prevent. We had some good luck early on filling our South Platte reservoirs, and Stanley Lake did fill this year, but the partners have been drawing on it pretty hard. So Stanley Lake is down to about 98.3% of capacity. So let's go monsoon.
Yeah. Who else? I think, how about Justin?
Hello. Colorado Springs is sitting at 81% of system storage. That's just slightly below our long-term average of 83%. And year to date, we've seen about 7% more water demand than last year, but that's largely due to only having about half of the precip as compared to last year. But we have been getting a little bit more monsoon activity lately, and I do have some of the mosquito bites to prove that. But at this time, we don't have any additional watering restrictions or expectations of a shortage declaration. We just have the standard water waste prohibition and voluntary restrictions.
Okay. Is there anybody else who'd like to do a report? Anybody seeing something different or unique in your system? Anything else to report? Okay, looking quiet. All right, with that, I think we're at the end of our agenda. I'll just ask my partners, Ben and Megan, to speak up if I'm missing anything. There you are, Megan.
I think that looks good. I've been furiously taking notes. So thanks everybody so much for your report outs.
Yeah, really appreciate the engagement. It's helpful for us to get a better picture of what's happening around the state. So, all right, everybody, thank you for your attention, and we'll see you next month.
See ya.
Bye-bye.
Thanks,
Thank you.